and use that to help us understand Washington's estate. 3D provides the perfect medium for being able to explore the landscape of Mount Vernon. And plus, it's just plain fun to be able to fly around in 3D, explore the estate from lots of angles, and see everything that we're used to seeing out on the ground. Let me take you down to the Pioneer Farm, which is the home of an accurate reconstruction of Washington's 16-sided barn. Here you can see that 3D allows us to visualize the buildings in their landscape, just as they were meant to be. Landscape data and structure models are merged into one seamless experience. Another great way that GIS helps us is allowing us to explore the evolution of the estate through time. Today, the estate is only 425 acres, but at the time of Washington's death in 1799, it was a full 8,000-acre estate. Let's take a look at that plantation as it is today. Here you can see that Washington divided his property into 5 separate farms. Today, the estate covers Mansion Farm, which is shown here in red. The other 4, as you can see, are now completely covered in development. Let's compare that with Washington's 1793 map of those 5 farms. By linking these views together, we can maintain the same perspective as we explore Washington's River Farm in both 1793 and in 2015. Here on the left, we see River Farm as it is today. On the right is a virtual reconstruction of how the river farm might have looked based on Washington's map and a 1796 description of the property. Now, this model looks impressive, and you may think that it took a long time to create, but it's actually quite simple to do when using procedural rules. Here we look at Washington's River Farm barn, which is now beneath the north end of Stratford Landing Elementary School. Now, the historic reconstruction was a little more challenging, but is still able to be accomplished using procedural processes. Washington's description of the property and the barn in particular gave us the procedural parameters that were needed to create this model. Now, unfortunately, the fingers of progress, which Pamela Cunningham warned us about, have already taken over the river farm. But the Mount Vernon Ladies Association pioneered the concept of viewshed preservation in order to help protect what Washington saw across the river in Maryland. As viewshed manager, part of my role is to monitor the development that goes on across the river and analyze it to determine what its effect might be on the view that Washington loved and that our guests still experience today. Because we're in a river valley, the majority of the visual screening is covered by trees. In this view, you can see how LiDAR allows us to accurately model the tree canopy. This tree canopy model is the basis for our analytical viewshed model that we use to study the viewshed. This model was created in conjunction with the Chesapeake Conservancy, and we use it to see exactly how much of a development would be visible above the tree line, as well as what are the specific trees that provide the screening for that development. Let's come in and take a look at this subdivision that's highlighted in blue here that's within the viewshed. Our analysis indicated that all the trees that provide screening for this development were located on a single adjacent property. As a result of these findings, Mount Vernon worked with several partners across the river to work to place protective easements on this particular property in order to preserve these trees and continue to shield this development from view. Now let's go back over to the mansion, onto the piazza on the east side of the house, where we can take in the view, just as Washington might have done over 200 years ago. As you can see, GIS is helping me at the estate and viewshed levels, but GIS is also helping my colleague as he works to preserve Washington's architectural legacy. Allow me to introduce my colleague, Deputy Director for Architecture, Thomas Reinhardt.
Thanks, Eric. The fingers of progress that Eric confronts are not such an issue on the estate itself. It's the ravages of time that are the greatest concern to Mount Vernon's architectural team. We're charged with preserving Mount Vernon for future generations, and to do this, we need to understand the history of our historic resources. Our greatest challenge is organizing the massive amount of historical documentation that informs our work and provides content to other scholars and our visitors. In an attempt to do this, we've partnered with Quinn Evans Architects to create a Historic Building Information Model, or HBIM. This 3D model visually associates data with the individual parts of a building. We started with a laser scan of the building and modeled the structure in Revit. Revit's a great program for creating that model, but it does present challenges for data retrieval. What we needed was an intuitive platform to provide the model to our stakeholders, and a 3D view in a web browser was the solution. So let's peel back the rusticated siding of the house and enter the new room, which was the last addition Washington made to his home. It was completed in 1787. Once inside, we can associate data with any part of the room, from the large Palladian window right down to an individual doorknob. Let's look at the south wall. It was plastered by Richard Tharp in 1787. But notice these unhighlighted areas. These represent repairs carried out on the plaster in 1950. That may seem to be a rather insignificant detail, but if we think about the practical applications, we'll see how useful that is. We're in the process of upgrading our fire suppression system. We would much rather put a sprinkler head in 1950 plaster than in 1787 plaster. And when we conceived of this project, that's the level of detail we wanted to get to, and now we have arrived there. We can provide the model to consultants, such as our fire suppression engineer, who needs to route the system through the framing of the house in the least invasive way. And by providing him the model, it's like literally placing the house on his desktop. The integration of buildings and landscapes in a 3D environment is a powerful tool for us to accomplish our mission, which is to ensure the historic integrity of George Washington's home for generations to come. Esther?